So I want to end up with an overview about what test solutions we can offer. So for the non-thermal effects, which are described in Annex 2, we have the DC, the 0 Hertz analyzer based on induced current in a coil, in an isotropic coil system. That is offered by the system on the left. Then in the middle here on the non-thermal effects, an analyzer for measuring electric and magnetic field selective. The ELT for broadband analysis. Then on the right, in the middle here, we have the thermal effects. Starting from a few kilohertz up to 100 gigahertz for broadband testing with different systems, either coil diode systems or dipole diode systems or thermocouple systems. Then the spectrum analyzers with broadband antennas to allow for selective measurements in the range from 9 kilohertz to 6 gigahertz. And on the right hand, personal protection equipment, which is alarming you in the range from 100 kilohertz up to almost 100 gigahertz, 50 gigahertz up to 100 gigahertz. Depends on the curves. Of course, you don't have steep curves. Yeah, all these filters have always a certain steepness. So it depends how you define 50 gigahertz. I think 50 gigahertz is the 3 dB. But at 100 gigahertz, we still have a 6 dB attenuation, so you just still can pick up 100 gigahertz signals for the personal protection. You know, many signals are now reaching up to 100 gigahertz. For example, distance radar for cars, they work up in the range of 70, 80 gigahertz. You have more and more digital microwave links for offloading 3G, 4G, and future 5G systems. So you have digital microwave links from one E-node B to another E-node B, also in the range of 80, 90 gigahertz. And some countries like Poland, for example, they say everything which is on the roof must be tested on the roof. So if there are digital microwave links going up to 100 gigahertz, then you also need to have a 100 gigahertz probe to measure that. That's the reason why we just launched a 90 gigahertz probe. And we have a partner in Poland which is also offering accredited calibration up to 100 or 90 gigahertz. Personal protection equipment, yeah, so like using alarm devices which ensures that in your environment there are no electric and magnetic fields above the allowed level. Yeah, so as I already pointed out, the ELT 400 is covering the magnetic field from 1 Hertz to 400 kilohertz. The HP50F is offering electric and magnetic field weighted peaks done by both, but the EHP also offers selective measurements. Then we have another spectrum analyzer which looks almost the same. It's only gray. That is mainly developed for shortwave radio, also electric field and magnetic field up to 30 megahertz. And then of course for the higher frequency we have the yellow spectrum analyzer there. So the main applications are high power lines, railway, welding, tempering, smelting, magnetic resonance tomography, galvanization, power supply, transformers, so all what is in the low frequency range. Yeah. These instruments allows full autonomy up to 24 hours with the data logger, and has all the weighted peak ICNIRP 198, 2010, and the EU directive limit curves on board. Has a very high dynamical range of more than 100 dB thanks to the spectrum analysis the ELT 400, which is only approximately third of the price, third of the cost. Price performance is the same because it only performs a third of the measurements, but it has also, of course, the weighted peak on board. It can do magnetic and wideband measurement, and the EHP 50 is a little bit more sensitive, is also in the magnetic field. On the other hand, the ELT 400 is going up to 80 millitesla. It also fulfills measurement for domestic appliances, the IEC 62233, where you have a weighted peak RMS, not a weighted peak, but a weighted RMS detection. So that is also available in the ELT 400. But you also have an output, an analog output, 3-channel output, so you can put it into an oscilloscope, into 3-channel oscilloscope. And if you have an oscilloscope which is doing the FFT and also have curves, then of course you can also upgrade it to the EHP functions. The measurements, we also combined the unit if you want to use it in the field. So if you do electrical fields, you must do it on a wooden tripod to allow for accurate measurements. For magnetic field measurements, you can put it on a handle and use the NBM as the readout display of the EHP. Alternatively, you can connect it with a plastic optical fiber and have the reading on the notebook. So this combination with the EHP and the NBM, you can measure from 1 Hertz then up to 100 gigahertz. Yeah? So inside the EHP looks like that. So you have the 3 electrical sensors, EX, EY, and EZ on the bottom. And you have the 3 magnetic coils, HY, HZ, and HX. So field capacitive plates and magnetic sensor coils. You even have an auxiliary input there. So you can use this also as a spectrum analyzer for low frequency. Charger, power on-off status LED, and the operation and control via the optical link. The standalone operation is ideal for long-term measurements, allowing recording of various operational conditions of complex machines, for example, or if you want to do an assessment in railway or in a complex transformer station where you have a lot of loads which you are switching. So you can pre-configure the logger software. Storage intervals could be 30 seconds or 60 seconds. So more than a day you can measure the current value, samples, linear, median averaging, wideband or highest peak results. It's automatically stopped then after 24 hours. That is the user interface if you use it with a PC. So you can read out test results, set up different spans, spectrogram and waterfall displays if possible, isotropic spectrum and additional display of the X, Y, and Z components individually. You can have simultaneous E field and H field results, not really measurements. The measurements are of course taking quasi, they're of course serial, but they can be very, very fast. You see the exposure limits. You have a marker, set the different input ranges and the input attenuators, for example, electric 100 kV or electric 1 kV, magnetic 100 microtesla, 10 microtesla, or you perform dual measurements, the spectrum view or the weighted peak in time domain, so frequency and time domain you can select on the left. You get some of the weighted magnitudes. It's not weighted peaks, that is the sum of the magnitudes. You can start the waterfall. See the battery there. So you can have a waterfall diagram. You can put in a marker. The marker is giving you the results then in 2D or 3D in time, frequency, and amplitude. Yeah. That is weighted peak over time. So you see also the changes of the weighted peak over time. You see the instant weighted peak value, if it's compliant or not compliant. And you can, in the field, you can use the NBM as the readout display for the magnetic measurement, where you can directly have both instruments in your two hands. Or for electric measurements, you should put it on a tripod. The operation is the same as if you use the broadband probes of NBM. Then the displays look like that. So you also have a weighted peak over time. So you can also have the histogram, weighted peak over time. Isotropic measurements with weighted peak. You can select the standards. You can have alarm functions with audible peeps, that you get a beep if it's above the limit. Yeah, a little jump into simulation. So the Workers' Directive offers you to do simulation, to do calculation, or to do measurements. One possibility is also to have a simulation tool. That is a software which was developed in a university in Germany, which has been further developed since almost 10 years. And it's basically this the solution of the Maxwell equation. So it's calculating fields, as I told you, from 1 Hertz up to 300 gigahertz, so you can simulate. It offers the field calculation in 3 selectable intersection planes and presentation as 2-dimensional surfaces and isoclines. It offers also a representation of the measuring and calculation data in 3D virtual reality. So you can also upload test results, and you can compare test results with simulated results. Its consideration the ground profiles and background maps, has project management functions, representation of calculation results as a percentage of limits, consideration of shielding systems, numerical and analytical isotropic. So this software is also, I think, I'm pretty sure the market leader worldwide. We are selling it almost into all countries. So there are different software packages starting from below 10 kilo euros up to 20 kilo euros. So you either have simulation only for 50-60 hertz, or only B field, or B field and E field. The EFC 400 PS is also simulating the sound which is coming from the high voltage lines. Then we have a TC version, so for high frequency, radio frequency simulation, and then some companies even buy the enterprise version. So if you are a utility company, a power transmission company, and you also have mobile systems on your pylons, then of course you might require really simulation from 0 hertz up to 300 gigahertz.